Welcome to the new series of videos on quadratic equations. So what we're going to be starting with in this video is going to be pretty simple. It's going to be very similar to what we did in the last unit. Because that's right, we are doing more factoring. The only difference is that now, instead of just having an expression here that we need to factor, we're going to set it equal to 0. So now we have an equation, and we can solve for x. This is a quadratic equation. But what we do is the exact same thing. We just factor this expression. So we need two numbers that multiply to 2 and add to 3. That's going to be 2 and 1. So x plus 2 times x plus 1. We've changed this expression into the factored form, so it's still equal to 0. So now, to solve for x, we have to think, what numbers can we make x in order to make this whole thing 0? Well, if we can get one of these binomials to be 0, then we'll have 0 times something else, which will always be 0. So how can we make x plus 2 equal to 0? Well, that would be if x was negative 2. Then we would have 0 times 1, which would be 0. Sorry, 0 times negative 1, which would be 0. We could also make this x plus 1 equal to 0, which would mean x would be negative 1. And then we would have 1 times 0, which equals 0. So by making either x plus 2 or x plus 1 equal to 0, the whole thing is equal to 0. So therefore, we have two solutions for x. Okay, let's look at another one. Same thing, we just want to factor this side here. So two numbers that multiply to 28 and add to negative 11. Well, we know that 7 and 4 will add to positive 11. So in order to make it negative 11, we're going to do x minus 7 times x minus 4. And now, to get this whole thing equal to 0, we can make x minus 7 equal to 0, in which case x will be 7. Or we can make x minus 4 equal to 0, in which case x will be 4. So there are the two solutions for x. It could be either one. Now, you might start with an equation that has something on both sides. In this case, you just want to rearrange it so that you have everything on one side equal to 0 so that you can factor it. So we're going to move the 12 over to the other side. It will become negative. So we'll get x squared minus 4x minus 12. And since there's nothing left on that side, it'll be equal to 0. Now we factor this. In order to get x minus 6 equal to 0, x will be 6. Or in order to get x plus 2 equal to 0, x will be negative 2. All right, now let's do a little bit more complicated factoring. Again, nothing that we haven't already done. Once again, we're starting with something on the other side, so we're just going to bring that over first. The 9 will become positive, plus 3 will be 12. So now, because we have a number in front of the x squared, we're going to draw our little factoring x. Factors of 2 are 1 and 2. Factors of 12 are 1 and 12, 2 and 6, or 4 and 3. So hopefully you can see that if we put a 4 there and a 3 there, this will be 8 plus 3 equals 11. And this will factor to x plus 4 times 2x plus 3. To get x plus 4 equal to 0, x will be negative 4. And to get 2x plus 3 equal to 0, this one's a little bit more tricky. So actually for this one, let's write that out separately. 2x plus 3 equal to 0. How do we make that happen? Well, we're just going to solve this like a regular linear equation. Move the 3 to the other side, we'll get 2x equals negative 3. Divide both sides by 2, we get x equals negative 3 over 2. So there are two solutions, x equals negative 4 or negative 3 over 2. Okay. Now we're going to start with an equation that requires a bit more rearranging. So now we have lots of stuff on both sides. So let's take everything on the right side and move it back over to the left so that we'll have nothing but 0 left over there. So this will be 4x squared minus x squared is 3x squared. 10x plus 13x is 23x. And 3 minus 11 is negative 8. All of that equal to 0. And now we will factor this. Let's see. If we put an 8 here, that'll get us close to 23. That'll be 24. And then we'll just put a negative 1 there. 8 times negative 1 is negative 8. And this will be 24 plus negative 1 is 23. So to make x plus 8 0, we'll make x negative 8. And to make 3x minus 1 0, let's see if we can do this in our head this time. If we were to have the equation 3x minus 1 equals 0, we would move the negative 1 over to the other side. We'd have 3x equals 1. Divide both sides by 3, and x would be 1/3. Okay. Here is the next one. So we're going to factor this by drawing the x, 1 and 2, and then the factors of 5 are 5 and 1. This will be 10 plus 1, that's 11. So that does not work. So let's try putting the 1 here and the 5 there. We'll get 5 plus 2 is 7. That doesn't work either. Now, why is that? Are we forgetting something? No, we're not. These are all positive numbers, so we can't have any negative coefficients in this x here. It turns out this is actually the first quadratic expression we've seen that is not factorable, at least using any of the methods we've covered so far. This is not factorable. There are some quadratic expressions that just can't be factored, and we will cover future methods on how to solve for x in these types of expressions in later videos. But now let's go back to something that is factorable. This is going to be a long one. A long equation. We'll throw in some fractions there. Okay, so where should we start with this? Well, let's get rid of all the parentheses first. So we'll distribute this negative here. And then we'll distribute this x here. So we'll get x times 3 is 3x. X times negative 5 over x. Well, if we have x, we're multiplying by an x here and dividing by an x there. So those will cancel each other out. So then we'll just be left with the minus 5 on top there. Now we still have a fraction here where we are dividing by x. So in order to get rid of that, let's multiply everything by x. Yes, we do have to do that just to get rid of that one little fraction, but that is going to make things easier. So the x changes to x squared, 3 changes to 3x. This will become an x squared term. So will this. And 36 over x times x will just be 36. Now, combine the negative 5x squared and the 15x squared to get 10x squared. Actually, let's see if we can do this all at once. Negative 5x squared plus 15x squared is 10x squared. Minus 3x squared will be 7x squared. 3x plus 5x is 8x. Plus 11x will be plus 19x. And then 36 will be brought over to this side as well, so it'll be negative 36. Yes, I believe we did that right. And this one, this is interesting. It looks like a much stranger problem than that one, but this one over here actually was not factorable, even though it looks very simple. And this one is factorable, even though it looks kind of strange. So we'll have 1 and 7 over there. How do we get to 19 using factors of 36? Factors of negative 36? Well, you know, we could waste time trying all different combinations, but since this isn't a video where I'm teaching you how to do this, I'll just give you the answer there. And this one was pretty difficult anyway, but hopefully you would know how to do that. Anyway, so we're left with this. In order to make x plus 4 equal to 0, x will be negative 4. And in order to make 7x minus 9 equal to 0, 7x equals 9, right? We're solving this equation here. 7x minus 9 equals 0. So we move the negative 9 over. 7x equals 9. X would equal 9 over 7. And you can see that that works if we put 9 over 7 back into this problem. 9 over 7 times 7 is 9. Minus 9 is 0. So putting 9 over 7 into this expression does make it 0. And that is why it is a solution of x. So you see you always have two solutions for x in these quadratic equations. So pretty interesting that we started with a crazy equation like that, and we were actually able to not just simplify it, but actually find out what x is equal to. So we're not going to do that here, but if you were to put this interesting fraction of 9 over 7 back into this original problem here, these two sides of the equation actually would be equal. That is what we solved for. Okay, so before we continue with solving quadratic equations, we're going to take a bit of a detour in the next video to go over simplifying square roots, which is a very important skill before we move on to more quadratic equations.